Okay, so we just dumped our dictionary. Now I think it's probably worth explaining what I'm trying to build here. So now we've built it, I can show you. It's a dictionary of what are called trigrams, because they're 3 characters long, 3 tri, for each key. So what you do is you take the source text, which we just copied off of Daring Fireball for some text, and basically if you look at text, English text, then the probability of an O following a Y is probably higher than the probability of, say, a Y following a Y, or a Z following a Y, or if you're American, a Z following a Y. So what a Markov chain does is it actually works out the probability of a letter following another letter is as not as just the probability of that letter being in a word, but it's also dependent on the letters that precede it. So once you've got a Y and a U, a Y and an O, then U becomes quite likely. There's not very many letters after YO that are probably more popular than a U. So that's how a Markov chain works, to make more English-like streams of letters. So that's what we're doing. We built, basically we take the text and we make every trigram. So we go through the whole text and take every chunk of 3 letters and note down what letter came after it. Whether it's a space, spaces are going to be important for the break-up-out words. Or whether it's a letter, so the letter after M in computer is P, so we would go com gives you a P, but there might be some COM somewhere else in this whole text that has another letter after it. Like let's take Facebook, so FAC, you could have E, which is face, or T to make fact. So these are all basically we're storing all this up in this dictionary. And you can see here that TOP, top, could have an S after it to make tops, but is 10 out of these 11 are spaces, so 10 times more likely to have a space after it. And rather than collapse these spaces and make this a count, this is actually useful because we can just dip into this randomly and get the right proportion out. So we're going to keep it like this. It's a bit, the storage it could be 26 letters with a count, so 26 inches for a count, but as you can see, actually this is 11 characters, so you could say this is actually a better way of storing it. I've stored them as strings currently, but so we're not going to worry too much about storage. We've got a dictionary built, so we're going to use this code now in it for our Markov text generator. So if I move, we get given the text, so we can move all of this into here, and maybe need to put it in an init obviously. And instead of making a dictionary, we're going to make a dictionary. I'm going to make a generator. For text. And we're going to do something with that. we're going to take this assert out here. We can replace that with a normal assert. So we've got our dictionary now, so we can assign dictionary. Okay. We also want to probably assign starts, have a list of, obviously there's more common starts to words than others, so we can maintain a start list here. It's going to be a list of an array of strings. And what we need to do is we've got words here. We can map. Oops, open there. We can map the first letter of each word. And turn that into a set. Oops, wrong count. And then first letters. And the starting. So I'm going to remember that. Once we build our dictionary, I'm going to build our starts equal to dictionary keys filtered where first letters contains first. So this will take all the keys that have a first letter that is a starting letter from our set that we created from the first letters of the word. To be honest, I wonder if that's just going to be all the letters, but doesn't matter. We've got a list now. Then the next thing I'm going to do is this stores our data. We need to generate a sequence of letters. So we're going to conform to sequence and iterator protocol. And I forgot to do the timer, so we'll finish this piece off. So we want an element type a string. Can fill that. And the thing we need from a iterator is to make a next. I think we can just get away with a next. That's a string. So that's one. And we have a current key. I'm and call it iterator index, a string. And we're going to set that in our init. And next, so we reach into our dictionary. Gonna have to have a buffer, aren't we? So going to get the first, because we've started with, we've got an iterator index, we need to actually map that into our buffer. So this is transforming it to a string. So next equal if the buffer's empty, then let's put something in the buffer, which is going to be the dictionary at the current index. Here now we need to so here, and then we return the next. So what we do is we make sure we've got something in the buffer. Our initial buffer should be 3 elements, but we'll check that. Right. Now then, we should be able to, from here, cool. Oops. So let's make a 100-character piece of text. Okay, so run that. Since we're doing this, let's put in a space if it can't get anything. Teach us to use a force unwrap, won't it? Oh. Right, we need to make sure we start with an empty buffer. And we need to take the random element, wasn't there? So when we make a dictionary, And here we have it. The nearly to Appen sensory potlight shows and seems less indurated they lega making scording reta. So that is the random daring fireball type text generated by my Markov text generator. Here's another one. Equi received at 2 had used the of Idexcrimax. They even say septives is Bodhi would interval lately too. So it's not English, but it's English-like, and it's since this is a video game and we've been attacked by aliens, they've learned English by studying Daring Fireball, but they haven't quite got it right. And that is the backstory. Made up right now. So that's that for now. I hope that's, obviously it's been a bit fast going through what actually is a Markov chain and how we use it to generate sort of text, but basically we've created this iterate sequence which has got a next, and we choose a random element once we've got our dictionary for each next, and the dictionary is built by, as I say, chopping up the entire text into 3-letter trigrams. They're called 3-letter sections, and storing the next letter, and then when you randomly pick the next letter, it will pick in the same proportion as you kind of scanned it in, so that's why it looks like some kind of English. Okay, that's enough for this one, so hope you enjoyed it. See you next time.